Hello, we are talking to Daniel Povey, and can I ask you what is BPE?
BPE. So BPE stands for Byte Pair Encoding, but usually when we use that word in a ASR context, we're talking about word pieces because so byte pair encoding is just a specific algorithm that's quite simple, that it's become popular as a way to break words into little pieces, like if one or two or three letters. So the issue is that these days we want to have open vocabulary systems. We want to not be limited to a fixed vocabulary, and that's especially important in languages like German that have a very open vocabulary. So we don't really want to use words, but also often we don't know how words are pronounced. We don't have like a lexicon, so a mapping from phones to words. So we just make a dictionary kind of on the surface level of the characters by breaking each word up into a sequence of little pieces. And there's like a deterministic algorithm, so that given a word, you always know how to break it up into pieces.
Okay, could you tell us why we switched from LM to BPE?
Well, okay, so it's not that we're getting rid of LMs necessarily. Uh, so traditionally, we used to have this HCLG business, the traditional graph-based decoding. So we had a lexicon that mapped phones to words, and we had a language model on words. These days, there's a lot more choices because some of these end-to-end models can decode quite well without a language model. But you can still combine a BPE with a language model. So you have a choice to either build a language model on BPE units or build a language model on words. That would require like a fixed vocabulary. So it's kind of a waste because you're not getting the benefits of an open vocabulary then. But you could build a language model on words and then build a lexicon that just maps words to the sequence of BPE pieces. So you can still use a language model. The thing that we're getting rid of is the lexicon, the dictionary, because we don't need this word to phone mapping anymore.
Okay, you said benefits of an open vocabulary. What are those?
Well, the benefit is that you're able to recognize words that you never saw in training. But of course, the downside of it is that you could easily get things wrong uh, because it's generally hard to recognize unseen words. For instance, if I tell you some word that you've never heard before, you might have a hard time knowing how to spell it, right? Uh, and so it's kind of the same thing with ASR systems, that they might get these things wrong. But these days the accuracy of the models is getting better and better, so that we're actually starting to see benefits in whatever rate from having an open vocabulary system. You sometimes see a small benefit. Back when I was starting out, back around the year 2000, when people tried these open vocabulary systems, uh, it would always make the word error rate worse, because anytime you would recognize an unseen word, it would almost always be wrong. But these days, that's not the case anymore.
Okay, there are many types of BPE, like 500 or 1,000. What are the pros and cons and the differences between those?
Oh, okay, so we may be talking here about our icefall recipes that if we look at your screen there, it's got lang BPE 500, 1000, 2000. So our data preparation script, by default, we run the BPE algorithm with different numbers of target pieces. We tuned our systems and we tried different numbers. But I think in the end, we found that 500 worked the best for us. This is for English, I think. So mostly we just use the 500. But it is kind of language dependent, because so someone recently pointed out to me or told me that in a German system they were working on, they sometimes we're getting some warnings from Icefall about transcripts that were too long relative to the number of frames. So they were running into a limitation of the system in certain configurations can only output one symbol per frame. So these long, complicated German words, they just had so many letters in them, and they were speaking so fast that it required more than 25 symbols per second. So they were running into that limitation. So if that happens, you would definitely want to increase the BPE size from 500 to 1,000 or 5,000, because then you're going to have to output fewer of them per frame.
Okay, why did you say that 500 was the best option?
Well, we just tuned it for some of our English systems, and what we found is that we were getting better word error rates from the 500 vocabulary size BPE.
Okay, for language, okay, for low resource languages, would you pick a certain one, or would it just be how fast they're talking?
Well, I think it mostly depends. It might depend on properties of the language, but generally, I'd want to pick a small number for a low resource language, because if we don't have a lot of training data, we're not going to be seeing many instances of any given one, right? So we're a bit more concerned about, we don't want any super low count BPE pieces.
Okay,
Yeah.
got it. Could you walk us through these different documents?
Oh, okay. So now, firstly, I want to mention that this Lang phone, this is kind of a Kaldi style, a slightly Kaldi style language model directory, or like we're doing Kaldi style graphs. And now not all of our recipes actually use this. We support various decoding modes in, say, our RNNT systems. In some decoding modes, we don't use any graph or any language model at all. In some decoding modes, we do, and it doesn't always even help that we do use a language model. But because we're trying to develop systems that interact better with language models, we still keep this stuff around. So let's look at the BPE.model first. I think that's just a binary file. Click on the BPE.model. Oh, that's just some binary file. It's output by Python. Don't do open anyway. It's just going to be junk. Okay, HCLG.pt maybe. Oh no, that's also binary. That's HLG. That's a compiled graph in like K2 format. So lexicon disambig.txt. This looks like just a BPE lexicon. The underscore on the BPE piece means it's the start of the word. Uh, Again, this is not something that's really necessary to decode with always, because if you have BPEs, you don't have to be limited to a vocabulary. But if you want to build language models that are based on words, you have to do it this way. The disambig, you can click on lexicon.txt. The only difference here is that you don't have those #1 things at the end of the sentences. Those are to disambiguate in case two different things had the same decomposition into BPE pieces. In fact, I'm a little bit surprised that we have these #1s, because the BPE decomposition is deterministic both ways. You you can't you shouldn't be able to have two different words mapping to the same BPE thing. Can we click again on lexicon disambig.txt? Okay, let's look at this. No, keep it still. So abbreviation versus abbreviations. Oh, okay, I remember now. So these #1 things, they're not just for where you have two things with the same pronunciation, like homophones. They're also for where one word is a prefix of another. So here, abbreviation like you can end the word there, but you can also add an S. And to keep the thing determinizable easily, we need these pound sign. We need these disambiguation symbols. Okay, that's that. Let's go to P.arpa. So I think the reason that we called this P.arpa, the ARPA format is a format for language models, for n-gram language models. This is probably like a trigram language model, I would guess. It must be at least bigram because I think the third field on those lines is the backoff probability, which we wouldn't have if it was a unigram.
What do these numbers here mean?
Well, I think those are the log of the backoff probability, the one on the right. The one on the left is actually the language model probability. These, I think, are unigram probabilities. So meaning if you don't know the history, or if you have a rare word on that you've just seen, this is the probability of the next word. And they seem to be sorted by probability, so we got the more probable word pieces at the top. Anyway, the one on the left is the log of the language model probability. The one on the right, these days nobody likes to use log 10, but that was back, this is a very old format, and at that time people still sometimes would use it. I guess it was invented by engineers or something. Yeah. So anyway, this is a language model on BPE pieces. Like I said, there's many different decoding methods that we use. And in this one, is for where you want to open vocabulary, just want a simple language model on BPE pieces. This doesn't always give great word results. I think language models don't tend to work so well if the units are too small. Especially, I mean, n-gram language models don't work too well if the units are too small. Okay, let's go to P.fst.txt, the next one. And let's go, yeah. So this one is created from P.arpa. It's like an FST format of the of the language model. Like there's a way that you could turn language models into finite state transducers. It's all described in Mihriel Mori's Springer Handbook paper, MOHRI. Sorry, Springer Handbook chapter on FSTs. Anyway, so I think the first and second fields are state IDs, the 1 and like the 447, things like that. The next two fields are those are like symbol numbers in tokens.txt, and the last one is a negative of a log probability, and it's in log base E. So these are a little bit larger than the ones in P.arpa, but there is actually a one-to-one correspondence between these things and the ones in P.arpa. Okay, let's go to tokens.txt. Yeah, so these are the BPE pieces that the algorithm created. The first three ones are like special ones that we told it to add. So those wouldn't have been created by the algorithm, but they're just put in there by us. They're blank, start of sentence / end of sentence, and unc meaning unknown. I think we don't always use this unc thing. We may have that there for historical reasons. Yeah. Okay, transcript tokens.txt. Okay, this is the training transcripts that have been turned into BPE pieces. So if you look at these, you can see that each underscore corresponds to the start of a word. The reason this is existing here is that we created this when we wanted to build a language model. We don't actually need this at this point. We could have deleted it, but we kept it around so you can see, I guess. Go to transcript words.txt. This is going to be the same thing, but in whole words instead of BPE pieces. Yeah, these are everything is a bit old-fashioned because the LibreSpeech, these free audiobooks, they're all like public domain stuff. So because of US copyright law being super long lasting, they have to be more than 80 years old or sometimes more than like 100 years old. So that's why it's really old-fashioned. Okay, let's go to words.txt. Words.txt. So this is just a list of all the words that are present in the LibreSpeech training transcripts, and each one has a number. These numbers would be present in L.pt in the lexicon. Yeah, but that won't be visible by humans. I think we haven't written to disk the text format of that. Okay, so that's that.
Okay. Also, one more
Maybe
question.
that's enough for today. I think. Yeah.
Okay, just one more question.
Mm-hmm.
Why did we change? Okay, there used to be HCLG, and now we're
Yeah.
not seeing the C anymore. Where did the C go?
Oh, yeah. Good question. So the C is for context. So back when I was starting out, in fact, for decades, we had these context-dependent phones. So that the idea is that the English language has, let's say, 40 or 30 phones, sounds like s, k, u, a. But they're sometimes pronounced differently depending on what the previous and the next phone are. So to kind of handle that better, we had this concept called triphones, which is a phone together with the left and right context, and then we would like cluster the triphones. So that whole process, to decode that, we created this thing called C that maps from phones to context-dependent phones. But these days, when people build neural net-based systems, they often don't use this context dependency because it's not so helpful anymore. So it's not necessary anymore.
Okay.
Yeah.
And we replace that with P?
So P isn't really a replacement for C. P is just a language model on phones, or not really on phones. It's really on BPE pieces in this case. So this is when you don't want to build the whole HCLG. You just want to have one thing that's just a language model directly on the BPE pieces. I'm not saying that this is necessarily the best way to decode. It's just one thing that we were investigating. It's one mode that we can decode in. Yeah.
Okay, got it. Thank you for your time. That was Daniel Poey. Bye.
Goodbye.